Thank you for joining for this episode of the TechSpective podcast. My guest this episode is Florian Noeding. Florian, if you want to introduce yourself, give a little bit of background on your role and what you do, that would be great.
Yeah, thank you, Tony. I'm a principal security architect at Adobe, and I oversee product and application security, and particularly our shift left efforts. That means I'm responsible for everything from security training, automated code review, to fuzzing included. And my cutoff point is roughly when we release software to our customers or it gets deployed to the cloud. By now, I'm 9 years with Adobe. Quite a long time. I first worked in Germany 4 years ago. I came over the big pond, over the Atlantic, here to the US. And yeah, that's what I do.
Okay, well, welcome. 4 years ago, I think sounds like a bad time to come over, but in general, I'm all in favor of coming over. Great place, usually. Yes, so that's the good introduction. I wanted to have you on to talk specifically about some stuff you guys have going on at Adobe around Project Kodiak. So to kind of lay the foundation, can you just give it like a brief explanation of what is Project Kodiak and kind of the both the what is it and why is it?
Yeah, sure. So Project Kodiak is our project to build a source code analysis platform for security. We looked at different ways of doing that and how to integrate security and shift it left. That means doing it earlier in the development process. So the key idea is we want to give our developers feedback in the pull request. That means we analyze source code changes, the change, as well as the whole repository, and we provide automated feedback. That is the very short summary. Why do we do that? Well, shifting left has a couple of advantages. It means we can do things much earlier in the development process where it's usually cheaper to fix. Also, it provides kind of a safety net for our developers. You know, writing secure code is really hard, even if you know all the security issues. I'm a security researcher too, but it's still really hard to write secure code. And having such a safety net is very useful.
That's probably a good kind of thread to pull on. I think for people who are not developers, especially people who aren't even technical,
yeah,
I think maybe it's real easy to assume that people are just being sloppy or they don't care or whatever. Like, well, why do you keep making code with vulnerabilities in it? Just stop. I think it's fair to provide an explanation. Now, granted, the audience of this podcast probably knows better than the average person on the street, but still worth discussing that there are hundreds of thousands, millions, tens of millions of lines of code, depending on the program we're talking about. And not only would it be bordering on impossible to get that 100% secure in the first place, but also the security, the threat landscape and the security landscape is a dynamic environment. So even if I say, hey, I've written this code and I guarantee you this code is 100% good right now, that doesn't mean that we won't discover something 5 months from now that makes it not good.
Yeah, that is very true. Maybe we can talk about a relatively simple example, cross-site scripting in a web application. So if I have a website and I take some input from my user and then let's say I can enter my name into a form field and then this name is displayed back to me. If I put some special characters in there and I don't take probably care of sanitizing or escaping these characters when I show them back to the user, well, a user might embed a script tag and execute arbitrary JavaScript. And that gives an attacker the ability to steal some data from me. So we need to avoid that. It sounds kind of simple to prevent that, but in practice, it's not. We're dealing with cross-site scripting since we have browsers that support it, basically.
Right.
And the situation is getting better. We have libraries that make it much easier to write secure code because you can't forget these escaping and sanitization step. But we have lots of software that isn't written in these modern libraries. An example would be React as a framework that is secure by default, how I call it. But for teams that have products where we can't easily replace it, especially because our customers depend, for example, on existing implementations that say modify to their needs, well, we need other ways of figuring out which data flows are there that are user controlled and which are not properly sanitized and escaped. And these things we can, to some degree, figure out in an automated fashion with software that analyzes software.
Okay. You've touched a little. This whole conversation was kind of about shift left, and going back to my earlier days when I was working in the trenches on the network admin and security analyst side of things. Once upon a time when I was at EDS, and I've talked about this in previous podcast episodes, one of my functions was to do sort of a security analysis of programs before they were released to production. And this is all sort of an anecdote to explain why shift left is valuable and important. This is around 2003, 4, 5. And in 2003, 4, 5, we were primarily doing waterfall development, and there was you gather requirements and you do all this stuff, and there was a 6 to 9 month process from gathering requirements to developing the code to saying, okay, here it is, it's ready for production. And if you at any point in that 9 months came up with another feature or something else that needed to be added, that went into the next cycle, and maybe you would put it in next year. There was no like developing on the fly. That was very problematic. It was very problematic because I was given it. I was basically the last step. The last step was, hey Tony, can you look at this and see if it's secure? What are my options at that point? If I say, if I either say, yes, and I, rubber stamp it and let insecure stuff go into production, or I push back, in which case everyone's mad at me, like I'm the bad guy, because they just spent 9 months developing this, and I say, no, you can't release this. The earlier we can get into that cycle and to incorporate security, to take a look at what can be done to improve security, the cheaper and easier it is, because it's a lot easier to just make a tweak early on than it is to unravel the whole program and start over 9 months from now.
Yeah, that's very true. And when I explain what shifting left is, I always talk about the process. People first plan, then they write code. They get their code reviewed, they build it, they test it, and then they deploy or release it in some fashion, and well, then they operate it. And shifting left is just doing things earlier, as we discussed. And just based on this example, if I can give feedback in the planning phase, for example, via threat modeling, then I can change the architecture easily because not a lot is yet written, especially if I have a greenfield project. If I give feedback in the code phase, well, we might discuss it later in giving feedback in an IDE, but in the review phase, if our developers follow a peer review model where they share their source code with their coworkers, ask for their feedback, and only then incorporate it, merge it into our product. And exactly at that point, we are doing the security analysis, and our developers already expect feedback at that point because, well, their coworkers do it too. I just add automated feedback in addition to that. That means when I give security feedback, the code change is still fresh in the mind of the developer or engineer. So it's relatively cheap to change, both from a context switching perspective and also from the effort in changing it. It's not yet
right.
on production. If Adobe has desktop apps, it's super hard to roll out a change to all desktop applications compared to a pull request.
Well, I was going to say, like, I can relate to that from the writing side of things. Like, if I'm writing something, if let's say I wrote a white paper, if I go back and review it, that evening, it's a lot easier for me to go, okay, yes, I remember I remember the chain of thought. If 3 months from now someone reviews that and comes back to me and says, hey Tony, we've got some feedback on this white paper, now I've got to go read the whole white paper again to like understand, okay, what was I even talking about and how does this fit into the flow? and whatever, you know. So it's having the real-time feedback means that I, as the writer or the developer, as you know, whoever's the creator of the thing, is still in that mind space, and it's a lot easier to make those adjustments.
Yeah, definitely. And I'm also thinking about it as an inline training tool. So not all engineers have the security trainings that I have received over the years. Well, it doesn't make sense to go that deep for most people. So we can catch issues that they are simply not aware of. And if you've been told a couple times, maybe once or twice, 3 times by an automated system, well, you introduced a security issue, you'll learn about it, you won't do it again in the future. So this is also a very nice side effect of having such an integration into the development process.
Right. So at its core, sort of, the ability to automate these things, and kind of the foundation of Project Kodiak relies on the fact that basically everything is code, infrastructure is code, blah blah blah. So from that perspective, can you describe security as code? Like, how would you explain security as code to someone?
Yeah. Let me start first with a non-security example. We have automated unit tests and integration tests. We don't call it quality assurance as code, but it is quality assurance as code. And security as code follows the same idea. We have a set of rules that we define. Or in this case, we have tools that execute these security tests. And we can, for example, say if we have a data flow that comes from is user controlled, does not go through a step that cleans it up and then is shown back to the user as HTML, then we have a security risk. So I can write a rule. It depends which tool, open source or commercial, you're using. And then you can codify your security expertise. You can also write a rule that says if you have a code pattern, a non-security example would be, just to make it very simple, you have a loop, a for loop, and if you call in a for loop a specific function, it should never be called in a for loop. I can write a security check for that too, or a code check in general that allows me to codify things.
Okay, so in general, but I guess asking more specifically for what you're doing within Adobe with Project Kodiak, for a code security platform to be effective and useful, like what would you say are kind of the key elements that you need to have?
That's a very good question. And there are a few key aspects in Project Kodiak that are most important to us. Our mission is basically to find security issues before our adversaries find them. But there are a few very important details. Finding potential issues, potential bugs, potential security issues, and figuring out the difference to an actual security issue and something that is exploitable by an adversary with limited access are very different things. And finding potential bugs is really easy. That means I could easily overwhelm the developers and engineers at Adobe with noise. That means one of the core tenets we have at Project Kodiak is that we provide low noise feedback. It means we really make a high focus on stuff that is worth fixing. I know that's a little bit abstract, but we carefully select what kind of security issues do we show. We carefully make sure that the rules we have, both for open source tools and commercial tools, are fine-tuned for Adobe's code base so that we just select few rules. It is also very important that any finding is actionable. Just if we tell give feedback, well, you have a security issue, that's not helpful. If we use language that is highly security technical, well, you have a CSRF issue would be an example. I can't expect that everybody knows that CSRF stands for cross-site request forgery. I can't also expect that people know how to fix that. What are the common patterns, or figure out if it's a false positive. Cross-site request forgery, it's usually It's most relevant if you have cookies involved. Many of our APIs and Webpack don't use cookies. Well, then you don't need cross-site request forgery protection. So these are thoughts that go into the rule selection.
Okay.
Going into it. Oh, yep.
No, I mean, if you have more to share on that,
I can go on for quite a while. This is an excellent question. The next aspect is being tightly integrated into the developer workflow. Previously, we asked our engineering teams to come to us to onboard to our security tooling. And we found simply integrating to the source code management system that they use and giving inline feedback in the pull request, or if you use a different platform, it's called a merge request, but same thing. It really helps a lot. And we decided to offer zero effort onboarding. So we just told them, well, we are going to onboard you. And step by step, we onboarded more than 95% of all of our Git repositories onto Project Kodiak. And nobody had to do anything but my team. That was really, really powerful to get started. Another aspect is fast feedback. If you have to wait a couple hours until an automated system gives you feedback on your source code change, it's probably already merged. Your coworkers work quicker. So we have a goal in most cases to give feedback within 5 minutes. For some programming languages that are compiled, well, we take a little bit longer. We sometimes need a build process to complete, then it takes 5 minutes plus build to give initial feedback. We have some feedback that definitely takes longer. So I can't do magic. Static analysis is a really hard problem to figure out, but we make every effort to give some feedback very, very fast. So in summary, make your developers happy. Talk to them, ask them what works, what doesn't.
Okay. Well, so all of that makes sense. A couple of things that resonate with me more in the broader sense, because I think it comes up a lot in security in general, is the actionable portion of it, because it's real easy for like us on the security side to just go, well, here, here's all the things that are wrong. We found all these vulnerabilities. We found all these, policy violations, whatever, configuration errors. Here's a catalog of all the things. But whether it's developers or end users or managers or whatever, it's like there needs to be the other part of it, which is, sort of like, okay, well, let me put these in order for you. Like, these are the ones you really need to work on, and these you can get to later. But also, what am I supposed to do? if I just give someone an error where I say, well, this domain controller is misconfigured. It's like, okay, and then what? What am I supposed to do with that information? So I think that is important, but it also then kind of leads me into my next question, which kind of flows from what you were talking about, which is for Project Kodiak, where does the information go? Like, who's seeing the output? Who's receiving it? What are they supposed to do with that information? And I'll add on one other little tidbit, which is sort of, who else sees it? Like if the information goes to the developer, is there also like a team lead that is seeing the information? Because to me, that part kind of comes back to the ongoing education aspect. Like, I want to know, using your example, if you've put a bunch of cross-site scripting vulnerabilities or whatever into something, and I give you a report and say, hey, here's some issues I found, can you fix these? And you fix them, great. But a month from now, I don't want to get another report where you've got a bunch of cross-site. You're like, hopefully you're improving over time, and I, as the manager, need to be able to see that yes, you are taking these things into consideration, and you're not continuing to make the same mistake over and over again.
Yeah, exactly. So we have a few different groups that we target. So our primary audience are, of course, the developers that write the code, so that they get immediate feedback if they have introduced a security issue in the code change. That is based on our pull request integration to our source code management system. We also have developed dashboards for Project Kodiak to give the engineering managers of these teams feedback what kind of issues they have. So they have sometimes long list of issues or often potential issues that we've identified, and we help them prioritize. We also support other security parts of the security team. For example, our threat modeling team can use Project Kodiak's information to decide, well, these are issues that have happened in the past, not only our vulnerability database that we have, but also things that are only in our source code analysis platform. We provide this information so that they can make a better assessment on which things to focus when talking to a team. We enable incident response too. So we have a bit over a year ago, we had Log4Shell, and everybody knows about it. So it's a pretty good example where we needed to figure out, well, where are we using a Log4j library? The platform like Kodiak can help answer that question too. We have a full copy of all source code, and we make it available to our security researchers so that they can look also for things that Kodiak does not yet have codified security rules for. Of course, we also target security leadership to provide data. A little bit of a surprising example would be on a high level, we have data, how effective our, or we are working on it currently, how effective are our training programs? Which percentage of the community introduces a certain kind of security issue? Do we need to change the way how we are training folks? Oh, that's very useful for data.
Yes, I mean because I think, and that comes back to a broader just business thing of just for no matter what you're doing, there should be some metric you can look at to try to determine, like, okay, was that worthwhile? Should we continue investing in that? Should we invest more in it, less in it? Is it working or not? I've had other people from Adobe on the podcast, and so I've talked about kind of zero trust initiatives. We've talked about different things that are that exist inside Adobe from a security perspective. How does what you're doing, how does Project Kodiak integrate with that security ecosystem within Adobe?
Yeah, so it's tightly integrated into the product and software security aspect. You might also call it application security. Static analyzers and software composition analyzers are no silver bullets. They can't detect all kinds of things, but they are highly scalable. So I can write a security rule once and apply it to the whole company. There are caveats, of course. Well, programming language support, library support in a programming language, and we can go down into a rabbit hole to figure out what coverage actually means. But it means we need to spend less time on specific kinds of security issues. So what kind of security issues do we have? Secrets in source code. As usually as an accident, for testing, you need usually credentials locally on your system. If you commit them accidentally, we can detect that and we can follow up with the developer. So that's not anything that anybody has to do manually anymore. We can detect a couple hundred different kinds of secrets in a fully automated version, directly alert people that they did a mistake. They can quickly revoke the credentials and be done with it. Or software composition analysis, so vulnerable third-party code, especially open source. And this goes a little bit into the SWAM topic too. Well, we can give feedback if there are issues. We can also inform, well, which are third-party dependencies we use across Adobe, which libraries are commonly used. We can inform decisions. And working together with our open source office to figure out how to improve processes around open source usage. SAST, static application security testing. Well, then we talk about mostly data flow concerns, but it also allows my team and all development teams across Adobe to implement custom guardrails, either on Adobe level or on a project level. So if you have some anti-patterns for a library you're using internally, well, add them to Kodiak, and you save some time during code review.
Okay. All right. So here's a question that I've asked in the past because it seems to come up frequently with Adobe in particular. Why build Project Kodiak as opposed to just buying a platform or tool that performs the same function?
That's a really good question. When we started designing Kodiak, we also looked at commercial options, but the commercial space for tools like Project Kodiak didn't yet exist. This has changed by now to some degree. I'm facing a few challenges at the enterprise level that smaller companies probably don't face. I have to deal with multiple source code management systems by different vendors. I deal with thousands and thousands of development teams that have unique processes. We have standardization, of course. We have a lot of shared infrastructure, but still we have a very diverse landscape inside of Adobe. Supporting that all is challenging. The second aspect is, yes, there are solutions. There are very, very good solutions for SAST and for SCA. So the first-party code and third-party code vulnerability detection. But it's not always coming from the same vendor. And secrets in source code detection might be another vendor. I certainly don't want in the pull requests of my development team 3 or 4 tools, and I'm looking at tools that can further augment Project Kodiak with more advanced features. Should I really add more tools to my pull requests? No, I should not. I want to provide a unified view. Our Chief Security Officer, Martin, talks about security as in speaking with one voice. So, Tony, you also touched on the topic of prioritization. In the future, I really want to provide a unified and pre-prioritized list based on all the context I have about a product or a Git repository to help teams make the right security decisions. I'm enabling security, but that means I need to simplify it so that all the teams without dedicated security experts can make the right decisions. And I'm not yet aware of a tool that fills all these gaps. There are tools that cover many aspects, and we have I have this source code search too. I can look for arbitrary regular expressions within seconds across my whole code base.
Right.
That's something only newly becoming available. Yes, there are specialized vendors, but they don't do security. So that's tricky.
I can definitely relate, and I'll switch gears for the anecdote. Like, my wife and I have, we've got various accounts, credit cards, checking, savings, whatever. We want to be able to manage our finances together, and so we both want access to see what's going on, and we need all of that stuff. We need all of the sources to be in one place so that we have that unified view. So I can say, okay, I know this is what we spent, and I can budget around that. We've been struggling for a couple of years now trying to find a solution that actually delivers that. We've used Mint. Mint's pretty, very good in a lot of ways, but it's missing a couple key components. Then we switched over to Rocket Money, also very good. It's got better reporting, but in both cases, neither of them is able to actually integrate with all of our accounts. And it's all right, well, that's a fatal flaw. I don't want to have a solution that does 80 or 90% of it, and then I still have to go manually do the other 10%. That doesn't really help me that much, So it's a similar thing, where it's yes, you could cobble together some solutions that would deliver the same net outcome, but it's how much effort is going to be involved on your end, and how much complexity are you adding for no apparent reason.
Yeah, the equivalent of Mint and Rocket existed back then too. But I not only needed to aggregate findings and display them, AppSec orchestration tools exist, or single pane of glass exists since quite a while. but I really needed a tool that could orchestrate these scanning engines and following a best of breed approach. So if you look at keyword here is kind of Wardley mapping. The idea is you can classify the value stream components that you have as Genesis, something that is completely new, to stuff that is commodity. Nobody talks about specifics in electricity or water supply. It's all highly, highly standardized. And that's the other end. We have highly specific things that are custom built, in this case, for Adobe. And there's stuff in the middle. Static application security testing tools, they are not yet commodities. They are not yet standardized. It's really interesting how different they are, how different they operate. Software composition analysis tools are more standardized. So we said, let's focus on the part that we really can't buy because it's still in Genesis, being figured out by the industry what the standard solution should be. So we have a bespoke solution for that at Adobe, while we use open source and commercial tools for the rest.
Okay. So another organization, I mean, Adobe's larger than most, but for some organizations, maybe there's a tool on the market that would kind of fit their needs better. But in a situation where someone's like, all right, if they're in the same boat as you and they say, I need to do these things, I have all these tools available, they all do 70% of what I need, but that's I need something better. If you were going to do it over again, like what are the kind of the cons or the pitfalls? Like what challenges should someone be aware of before they embark on creating their own Project Kodiak?
Yeah, the first is be really careful with the build or buy or adopt decision, so that you are really sure that you have to build. In my case, the driver was, well, even if I buy a commercial tool that has integration into various source code management systems, I still have to orchestrate the execution of the tool. So that effort gives me already a lot of what I had to build for Project Kodiak with my team. But it's really important to be very careful about this decision. The next most important decision is figuring out which SAST tool to use. And we evaluated multiple tools, and it's kind of surprising how they performed. And just because some tools are based on source code only analysis, some tools need a build integration, so you have to execute really a full build step, at least for some languages like C, C++, Java. And some just take a build artifact. That's often in the Java ecosystem. And that is one of the most important decisions to make. If you take something that is really hard to roll out because you need build integration or build artifacts, that can be very painful. So that's probably the most important decision around having something like Project Kodiak, or even if you decide to just buy a SaaS tool and integrate it into your source code management platform because you have only one, that influences a lot of the work you have to do.
Right.
Being able to roll it out across the company and get 90% of what a slightly better tool might get you with build integration, you're not going to get build integration across a large enterprise without lots and lots of help. And it might take, well, in first approximation, forever. It's also super important to have a tool that is highly customizable so that you can write security as code, custom rules that are specific to the problem domain you're facing. Just because you have a tool for Java doesn't mean it can deal with Java server pages, as an example. Doesn't mean it's aware of other frameworks you're using. So figuring that out. Stuff that I would do different. I would still build Project Kodiak today again. I'm not yet aware of a tool that fits my particular needs. So that I wouldn't do different, but I would prioritize things differently. We needed quite a bit of time to figure out what kind of feedback to give inline in the pull request versus what we should display in a dashboard. We had the belief initially we don't want to break the developers' flow and always keep them in the source code management system. And in retrospect, it turned out we need a dashboard because most source code management systems are not built to be extended in the fashion what we wanted to do. To have detailed dashboards in your Git repository is kind of hard in most source code management systems. So adding our own dashboard, something that we should have done much earlier. Another aspect is what I call differential scanning or analyzing net new source code. That's something I would have built earlier too. Giving feedback on all code in a branch or Git revision in general can be noisy because, well, in the past you probably have accepted quite some risk. It's all about acceptable risk. It's not about perfect security. Well, let's switch it all off. That doesn't allow us to do business. So it's about acceptable risk. And just analyzing the net new source code and figuring out files that have changed, code paths that have changed and now need to be analyzed, and highlighting these new issues that are newly introduced just now in the pull request. That's really the sweet spot. And we needed a bit to figure that out. And there's caveats to that too. We have some things where we, in a circular fashion, even while we say we only give in a pull request localized feedback, some security issues which we will always have to inform our developers about, even if it's an old code, because we have an effort to eliminate a class of security issues.
Because, so yes, it makes absolute sense to be able to do like a differential. Again, I'm going to put it back in writing context. I'd much rather have track changes on so that I know, okay, I already ignored that once. And that makes sense in this case to say, okay, I've already looked at it. I understand the risk. I've accepted the risk. I don't need you every day, every week, every month to remind me, oh yeah, that's still a risk because I already accepted it. But that said, and I think this is maybe what you were getting at, for some things, I'm like, okay, but on some periodic basis, whether it's 6 months or a year or something, you should come back to it and say, okay, are you sure you still want to accept this risk? Like you don't want to just ignore it forever just because I accepted it.
Yeah, there are two aspects to that. One is not everything has yet been marked as an accepted risk or a false positive. So especially if we onboard a new project that is already a large code base, hundreds of thousands of lines of code or even millions, then during the first scan, we will find a lot of stuff. And that is overwhelming. That's simply too much. So we need to focus on the things that are most important or most urgent, most severe in impact potentially. And that is where once you go into this backlog and you mark things, well, this doesn't impact me based on the context, it doesn't make sense. And then you can mark these all as false positives or accept them. But even then, you might still have a long list of things that are impacting that you decided you can't fix them. They are still in your backlog. And we don't want that these things pop up into every pull request. And that's why it's important to just look at the net new stuff and figure out what is net new. There are various ways to detect that. And correlating, source code changes. You can't use line numbers in a file because the line number will change during the next commit probably. So you need to be a little bit smarter in figuring out how do I track that this is still the same security issues that I alerted yesterday about or 6 months ago.
Okay. All right. Well, I mean, I think that does it for me in terms of my questions about Project Kodiak. So I sometimes like to kind of wrap things up with an open-ended question of, is there, do you have any closing thoughts? Is there something we could have asked that I didn't? Just anything else you want to add?
Closing thoughts, good point. I spend most of my time nowadays thinking about what my customers, the developers and engineering teams, what they really want to get out of it. So having good connections to the embedded security teams across Adobe and generally being open to feedback, how it's working, that is one of the most important aspects. So just talk to your developers. They have to deal with what you send them. ask for feedback, make it better.
Awesome. All right. Well, I want to thank you for taking the time. It was a good conversation, enlightening.
Yeah, thank you for having me. It was great.
All right, take care. I appreciate you investing your time to listen to the podcast, but I also invite you to engage on social media. Please go like our Facebook page and follow at TechSpective on Twitter and Instagram. You can feel free to let me know what you like, let me know what you don't like, let me know if you love it, let me know if it sucks, and let me know what products you'd like to see reviewed or what questions you'd like to see answered in future posts.